All right, Wiz. So we're seeing it again. All right. Instead of having to do all of the tough engineering work ourselves, we see another framework here. This time we're meeting Fenic that has actually built a framework for us. So maybe we can just leverage it instead. And this time we're getting data centric, right?
Yeah, that's right. I mean, exactly so. One of the things that's so interesting and cool about the space we're in right now is that like LLMs, AI is going to wind up augmenting many things. And sometimes we've been doing that engineering work ourselves, but it is getting to the point where now companies are starting to do it for us, starting to make it a little bit smoother, run like butter kind of situation, right?
That's right.
You're absolutely correct.
Okay. And we get questions from students all the time, but how do I deal with structured data? How do I deal with like this just difficult data? And we're just like, well, yeah, you're going to have to kind of deal with that. Fenic and the folks over at typedef appear to be trying to take the messy, not yet ready for the context window stuff and like add some structure to it, appropriately structure it. Some of it may remain unstructured, but basically turn it into that clean, beautiful, like ready for generation context, right? That's kind of exactly what we're going after today.
Yeah, that's exactly it, right? So it's structured data has been a thorn in our side since we've started with LLMs all the way back in the early days of Llama Index, right? It was still something that we were struggling with. GPT Index, if you remember that far back. And I do think that it's really nice to start to see people who are like tackling this problem head on to help us use the same tools we're used to and the same kinds of way we're used to, but with that little extra LLM magic.
Yeah. Okay. So not to get too meta here, but like one of the things I've done often with our streams is I've taken just the raw transcript and I've tried to do generations based on that raw transcript. One of the cool examples I saw in their repo was you could sort of take a podcast, take a stream transcript, and it could sort of identify the speakers. It could sort of remove any music or ads like in the beginning. It could sort of really, and then enrich it with summaries and sort of get it into this format that you're not sort of relying on the LLM to do everything from raw transcript anymore. You're actually doing the hard work of data processing that's going to allow us to get better results sort of out of the box of something that we send into an LLM. So, it seems obvious to me that this is going to add value the more we can get this problem figured out in the industry generally. And it's great to see the data-centric tendencies starting to bubble up to the surface here. An indication of maturity, perhaps.
Well, that's exactly it, right? It's nice to see that we're not just focusing on the immediately flashy, right? We're actually focusing on like the hard part that matters a lot, right? Which is how your data looks, where your data is, what format it's in, and then transforming different kinds of data into types of data we know are better for our LLM based systems. And exactly like you said, adding these, pieces of extra power along that pipeline helps us actually be data centric, right? It helps us actually start living up to kind of the hype that we're supposed to be data centric, right? This kind of tool is how we can hope to achieve that.
Yeah. So the data science is finally being integrated, and we've got the right guy who built most of this thing in the house today. I'd like to welcome Rohit Rastogi to the stage. TypeDef, founding engineer, Rohit, where you're building literally the stuff we're going to look at today. Previously, you worked on AI observability, and you're ready to nerd out with us today. You got background with large-scale platforms at Google, and you've thought deeply about this data pipeline problem. So tell us just the TLDR real quick on like what is the tool we're going to look at today, and how long have you been building it?
Awesome. So first of all, thanks for having me. So what is Fenic? Fenic is a DataFrame library, not too dissimilar from something like Pandas or Polars or PySpark, but So if you're familiar with those things, you'll be kind of familiar with the interface that Fenic provides. But what Fenic adds on top of those things are what we call semantic operators. So they are basically LLM-based functions that kind of have analogs to the traditional data processing world, where you're basically inserting an LLM, but you have a similar interface as you would the actual polars or pandas. So for example, a very common operation in the data frame world is filtering, right? You might do a dot filter or dot where, and you pass in like a Boolean predicate there. So maybe is X greater than 5 or something. What we've done with Fenic is we've kind of expanded that concept to also work with natural language predicates or prompts. So you basically write a prompt. We use structured outputs to always guarantee that the prompt is going to return a Boolean value. And then you can use that Boolean value that the model generated for every row to do your filter. So we have a few of these concepts that map from basically the LLM world to the traditional data world. We also have some AI or AI adjacent specific types in the data frame. So if you've used polars and pandas before, you're probably familiar with strings and ints and floats, objects. But in Fenic, we also have first-class support for embeddings, JSON for semi-structured data, and Markdown documents, and then also some support for like parsing transcripts. So that should help doing a lot of the messy data munging, as you guys mentioned, to get the data in tip-top shape before you're ready to send it out to the model.
Okay,
So,
Wiz, it sounds like we got the right guy today. I mean, it sounds
I think probably we do, Greg. I think probably that's right.
Okay. Well, let's kick this thing off, guys. I'm going to do a quick intro to let everybody meet typedef. We'll hear a little bit of background on the company. You guys just raised your Series A or your seed, 5.5 million. Congratulations on that. And we'll hear a little bit about how Fenic came about and what you're going to build in the future too before the end of the show here. All right, guys, let's kick this thing off, and we'll see you back on stage here shortly. All right, everybody, welcome to another AI Makerspace event. This one is on Fenic, the data frame rebuilt for LLM inference from the folks at typedef, a brand new company. This was recommended by our friends over at RC that we check out. They were like, yo, you got to talk to Rohit. You got to talk to Yanni over at typedef. We couldn't turn that one down. So we're going to check out the leading edge, the LLM edge of the intersection of LLM inference and data frames here today. If you got questions along the way, you know what to do. Smash the chat. And as the discussions are going, we'll be watching. So get in on it, everybody, today. If you are watching on a different viewing platform, just go ahead and leave a comment and we will get to your questions. All right. So with that, let's meet typedef and Fenic. That's what we want to do today. And importantly, if you stick with us for the next 52 minutes or so, we'll get some indication of what the people on the edge are actually thinking about the future of building data pipelines. We're quite interested in the integration, really marrying the data pipeline with the agent applications today. And I think this is definitely where the industry is headed. So we're going to learn about how this works under the hood and how, of course, we can actually use it, and this new open source tool from them called Fenic will demo per usual. So Fenic, spoiler alert, is a type of fox, and we're gonna understand where that came from as we get into it today. All right, so typedef is this company that's recently been spun up, the AI data engine for modern workloads. There's quite a number of things that they are putting out there on their new website. Bring structure to unstructured, built for text analytics. Everybody loves that super fast Rust-based underbelly of everything. Everybody loves context engineering, semantic processing at scale. Okay, great. Operationalizing. That sounds really great too. And what we're talking about is OLAP meets LLMs, or online analytical processing meets LLMs. This does sound like the future indeed. Say goodbye to brittle UDFs, hacky microservices, and fragile glue code. Typedef brings structure and reliability. This is, I think, the key here. And one of the discussions we'll have today is, can we just ask an LLM to do this? And it's like, of course, you can ask an LLM to do everything, but will it work? And will it work reliably? Will it be programmatic? Will it be something that you can actually scale in production, or is it just going to be something that works every once in a while? This is kind of where we're focused in the industry right now. So we got models and data. We're going to put them into this typedef engine, and hopefully this magic perfectly structured context comes out. And they're really helping us to optimize all of that. So you got to love this, made for data nerds by data nerds. And, you know, typedef was founded on a simple premise: AI workloads need their own native layer. Okay, so let's start talking about this then with the experts here. So Wiz, Rohit, welcome back here. So let's start with you, Rohit. Why can't I just ask the LLM, hey, just structure this? I know what I want, like this, and I'll just put it in a prompt. This works, doesn't it?
It sort of works. I think if you do a really good job of tuning your prompt and giving lots of great examples, there's a decent chance you will get the JSON that you want. Obviously, if you use one of the constrained decoding sort of APIs, you will get exactly what you want. But the problem is bigger than just getting the right structure. It's more about how you take a complex task that you want the model to do and decompose it into a set of small steps. So we saw LangChain do that right when the GPTs kind of became, or when they started taking off as a framework to sort of decompose complex problems into sort of small, almost DAGs rather, that basically improve the likelihood that the model is able to do like a simple task really, really well. And then you kind of chain these together. So we're trying to do something very similar, but with batch data here. So you can imagine a data frame using Fenic is basically a chain of LLM invocations mixed with OLAP. And there's a good chance that if you're able to break down the problem sufficiently, each invocation of the model is going to do the right thing instead of having it to do this complex thing. So the idea here is if you want to get the right structure, it's also about, it's not just about the asking the model for the right output. It's also about how you frame the problem and how you decompose it.
Okay. Yeah. So Wiz, my sort of take on this when we were talking about this earlier is if you sort of zoom in enough, you can trust the LLM. Is this a reasonable way to think about, you know, down scoping the problem down to this task level? It's a really interesting callback to LangChain in the early days of LangChain. You know, I remember teaching it where it felt like everything was that sort of DAG, not the cyclic graph, but it was actually everything was linear. And so it's really interesting to think about typedef in this sort of linear phase of their development. You know, cycles to come in the future, something like that.
Yeah, I mean that's exactly right. It's this idea that, you know, of course you can prompt an LLM to do anything, right?
That's
like
right.
if you try really, really hard and you give it everything it needs, you know, you can get there. But that reliability, that reproducibility, the fact that we have to extend this now from doing this once to doing this 10,000 times or 100,000 times, this is where we need something better than just prompting. And I really like this idea, this framing, right? That the typedef folks were telling us, right, before we jumped on, which is like batch LangChain. I love the idea of batch LangChain, right? It's like we think so. It's a different axis, right, to scale LangChain than we're typically thinking about. So we're really oftentimes when we're talking about AI engineering, we're talking about some user is going to use this artifact, right? And that's primarily the interface through which our chain is going to be invoked, versus just like we can map functions across data frames in our favorite data frame frameworks, right? Now we can map these chains across them, and I think that's something that is very powerful for exactly the reasons Rohit already mentioned. So we don't have to recall.
Yeah. Oh, so Rohit, I mean, I guess I'm thinking here of sort of, you know, the way that we do evaluation on RAG applications, and we're trying to do them on agent applications today. And we sort of say, okay, we have this kind of idea that we don't want it to hallucinate for sure. Everybody can agree. And then we have these additional advanced sort of evaluation metrics that we can use. How do you think about sort of taking data and then, let's say, using an LLM to transform it, right? Sending it through the transformer, it gets to the other side, and then you're like, oh, that's definitely correct. That's good. That's right. How do you think about guaranteeing that this is going to, be consistent and, not hallucinate, let's say?
Yeah, definitely. So I think there's a few parts to that question. The first is, how do you actually make sure that the output is correct relative to the input? And the second is, how do you actually kind of frame the problem? So let me talk about the second one first. So what we're doing with Fenic is, well, of course, LLMs are basically text in and text out, right? You give it a prompt, and then you get basically text out. And with Fenic, what we're trying to do is actually constrain it to more of like a programming functional perspective, kind of similar in some ways to how DSP has signatures or DSP has signatures, right? So for every semantic operator that Fenic has, it has a set of inputs that it can take. These might be columns in the data frame. And for every output, you can define the output type depending on the semantic operator. So in the case of a predicate where you're filtering, you're always going to return a Boolean back. But you can also define arbitrary structs. So basically, we've transformed the problem now from string in to string out to columns in and some sort of well-defined output type on the output. So that helps you reason about quite clearly when you're building your chain or you're building your data frame program, the step is always going to give me this input and it's always going to give me this output. Data frames are extremely strongly typed. That's kind of one of the benefits of them. So at every step of the process in your data frame, you know exactly structurally what data is in there. Now, if you go back to the first part, which is how do you actually make sure that the outputs are correct outside of just the structure? This is where I think traditional evals come in, right? Just because you're doing this sort of transformation in batch doesn't mean that you shouldn't use LLM evals or LLM as judge. Like the same principles apply. So if you're doing a semantic map operation, which basically runs an arbitrary prompt across the data frame, you might want to chain that with a eval phase that says, how faithful was the output, or how grounded was the output relative to the input, like all the stuff that we are familiar with around like ragas, and we can still apply a lot of those principles.
Okay. So Wiz, I'm hearing we had the discussion with guardrails recently on sort of validation versus evaluation versus guardrails. So there's a little bit of all this also in the data transformation space prior to even getting into the app, in exactly the same way that we're putting evals and validation and guardrails on the app themselves, right? So it's almost like a whole different development cycle before we even get started or something.
Yeah, I mean, like that's so that is kind of the future of this kind of product, right? I mean, one of the things that I really want to make sure we lean into, that I'm really glad Rohit brought up and not me first, is this idea of having really good frameworks that we can use kind of actual engineering principles through, right, to interact with data with the LLM in mind, right, is very important. The reason I bring this up in this context, though, is, Rohit mentions DSP or DSP, which is this, a framework that we've discussed many times before, but kind of suffers this extremely, technical implementation that only dedicated people have the time to sift through, right? Versus this, which is it feels familiar, right? It feels usual. It's using similar enough APIs that it's not taking you out of the way you're used to working. It's just kind of adding that extra spice on top. And this is one of the best things about this. If you're used to using these data frame frameworks, you're coming in with a lot of background knowledge needed to use a tool like Fenic, and then the extension is what you're focusing on learning or trying to internalize versus fighting with the framework itself. And that certainly was my experience with Fenic as it exists currently. I'm sure it will it will
Okay.
continue to.
Yeah, I love that. I've been in quite a few meetings talking about change management from the top of enterprise recently, and it's almost like change management for the engineer, for the data scientist converting to AI engineer, for the software engineer that has some data science background. Yeah, I love keeping that in mind, because famously, when we try to teach DSPy in class, everybody's like, "What was that?" How do I even get my grounding, my footing? Okay, guys, let's introduce Fenic, and then we'll continue the discussion here on the technical details further. All right, so let's meet Fenic. Fenic is trying to solve this critical problem. The problem of unstructured data. We got all these PDFs, all this audio, these images, this video. Like, building these super clean ETL pipelines requires doing OCR. It requires transcribing things. It requires computer vision. There's so many different things that we've got to do to get things into the right order. And so, it's only after we do all of this that we can really start thinking about how to set up our pipelines, not just so we can get one quick prototype done, although definitely we want to have the right tools to help us do that. But, further, how can we start thinking about this in a way that's going to scale out, similar to when we learn to build a simple RAG application versus learning to build it with a scalable framework? Same thing here. And so this idea of managing this complexity is what allows Fenic to sort of slot in. And so opinionated PySpark-inspired DataFrame framework, the old frame, like MCP protocol. We see this again. And for building AI and agent applications. So, this idea that if we are going to, build a classic ETL pipeline, we all kind of understand how to do that. Well, that's cool in a previous domain where structured data kind of ruled the roost, but LLMs are natively really powerful with unstructured data. And so how do we basically, combine the best of both worlds? That's what we're trying to do here. We see common words like DataFrame, like finding insights throughout their documentation and their release blogs and their website. Their key insight here is that actually it's not such a different problem after all, that agentic workflows are just pipelines. We might say every agent is part workflow here, and every workflow that we have with LLMs is part agent. They take inputs, generate outputs, log results. They have some reasoning capability, of course. That's not so different. And so this idea of, can we get this pre-processing layer really right? We're just one step downstream from our actual agent application. Well, Fenic can help. When we're quite interested, Fenic, how did you decide on Fenic? Turns out there's an actual thing called the Fenic fox, small native fox native to the deserts of North Africa. So obviously it's got very large ears. Maybe that has something to do with it. Can listen to underground prey, listen to the data very, very cleanly. Maybe that has something to do with it. Maybe not at all. Let's find out. Guys, we've got a couple discussion questions up here. I'd love to hear from you, Rohit, about typedef and about Fenic first. So obviously typedef, it's like we've already talked about typing a little bit here today. And then why Fenic? And I think we already talked about why we started with DataFrames.
Yeah, so starting a little bit about why Fenic. So, well, the Fenic fox is this like super interesting, highly adaptable animal that lives in I think North Africa or in the desert. But anyway, it's very resilient. It's got a very harsh climate that it lives in, and it figures out ways to kind of adapt and survive. And that's kind of how we think of our library a little bit, in the sense that reliability is very important. As we'll get into with the demos, you'll see that we are basically doing inference currently by talking to all the foundation model provider APIs. And reliability is really important there, because we're talking to an external service. You might get rate limited, you might get all sorts of transient errors. So what Fenic does is it tries to handle all of that transparently, so the user never has to really worry about the fact that they're talking to this third-party API, right? So that's kind of why Fenic. Also, a lot of the other data frame frameworks that that are out there, pandas and polars, they all have kind of like cute animal mascots. So we wanted to jump on that bandwagon.
That's right. That's right. And so does typedef, does that indicate anything that we should be thinking about when we think of your company?
Yeah, so typedef comes from, I think, like C or C++. It's like how you can define like structs in the language. So it's very foundational to how you like build programs. And that's kind of how we're trying to position ourselves in the AI infrastructure world, is like being foundational to your workflow. So that's kind of why typedef, it's sort of this like key infrastructure, basically.
Oh, okay. Okay. All right. So, So Wiz, help me out. Help me set some context to this question here. So we've got this idea of we're talking about pandas, which I think most people know, and then we keep talking about polars as well, which I think fewer people know. And then now we have to talk about PySpark here, the PySpark-inspired. But there's, of course, like Spark and PySpark. Can you just talk a little bit about the ecosystem for maybe the software engineers coming in from less of a data science background, just to set the context for inspiration from PySpark?
Yeah, I mean, there is this thing that we like to use called a data frame. A data frame is a extremely, I think Rohit's already said this, but it's a very robust data structure, especially when it comes to types. So it is something that expects, values of certain columns to be specific types. It's something that you have a lot of control over in terms of what kind of information can live in it, where does it go. What that lets us do as developers is interact with these structures in a way that we're very confident about, right? In a way that ensures, like, when we use this operation, when we map something across this column, we know all of the items are going to conform to this particular, this particular type. I do think that's very important. PySpark, Spark, polars, pandas, these are all frameworks we can use to kind of manipulate or interact with through some API these data frames. And there are different advantages and disadvantages to the frameworks. Pandas, so familiar, everyone's seen it before, really easy to use. It's got a very simple, very fun API, but it's kind of slow. Polars is very fast, right? And it uses a lot of the pandas API, so people are comfortable to switch to it. It comes with a lot of PySpark is Spark with Python, perhaps
classic.
but more importantly, Spark is very fast, right? And can leverage can leverage compute way more efficiently than the other operators, and uses things like MapReduce and things like distribution to be very fast and very performant. And but at the end of the day, they're all just ways that we can manipulate this object that we care to manipulate. And so, in that same vein, Fenic is a way we can manipulate this object we want to manipulate, which is that data frame, right, at the end of the day. But this time, instead of just kind of the traditional stuff we've been able to do, like Rohit's been talking to us about, we're sneaking in some LLM goodness there. We're allowing the LLM to interact. And then something that is very important to all of these frameworks when we use them in practical applications, right, is this idea of chaining. Pandas, even pandas, okay, back in the day, way ahead of LangChain, right, loves to chain operations, right? The dot do this, dot do that, dot do that, dot do that, right? We've all seen that kind of wall of chained methods. And this is something that's very familiar, very usual to users of these frameworks. And so, just like those frameworks, but like LangChain, where we've added we've added the
language
into that flow. This is how Fenic is helping us, and I think that's very important to think about, because we do want to keep these little method chains, right? We want to keep them really atomic. We want to keep them really simple. We want to keep them really focused, right? And so this is which is the same as if you are using any of these other frameworks. So and this is what I mean when I say there's this mental load when you're learning new frameworks, right? Yes. And the fact that this looks and feels right, like frameworks we're likely already used to using, allows us to focus on the part that's novel, right? Instead of focusing on the rest of the flow.
So something like familiarity, something like speed, something like scale. Like Rohit, what's your now? Okay, what's the PySpark?
Let me maybe elaborate a little bit on some of the differences between PySpark, Polars, and Pandas, just to give everybody a little bit of a mental model.
Yeah, I love it. Let's go.
So Pandas is, I think, amazing because of the ecosystem, right? Like scikit-learn plays really well with Pandas, for example. So you can, and same with matplotlib, right? You can plot things, you can send things over to scikit-learn. The problem, though, with Pandas is that it's, it's a little bit slow because it's, I believe, like single-threaded for most of the data processing. Now, what Polars does is that it actually, under the hood, is running Rust. So the Polars bits, you're interacting with the Python API, but actually it's running Rust under the hood. And it's really, really fast because it's multi-threaded. So it's able to basically distribute all of the work that you have to do across all the different cores that are available on your machine. And then what's also really cool about Polars is that it offers something called lazy execution, which is a way to basically build a DAG of calculations. And then at the end, using their lazy frame API, you can do, I believe it's .collect, which will actually go and run the DAG. So what's happening when you call .collect is that it's actually optimizing a plan. So it's very possible that you write kind of suboptimal transformations that some sort of optimizer or compiler can improve. It's kind of how, like in PyTorch, if people are familiar, like things are actually compiled down, right? You're not actually running your Python logic. It's compiled all the way down. The graphs are being optimized. Something very similar is happening in a DataFrame engine that's lazy. It's exactly what's happening under the hood if you run like a SQL query, right? You write your query, it gets parsed, it gets turned into a logical plan. That logical plan gets optimized, turns into a physical plan. That physical plan gets optimized, and then it gets executed. So that's what Polars does that Pandas doesn't do, right? It has this sort of lazy frame API. And Spark is similar to some ways as Polars in that it is also lazy and has a compiler and an optimizer. The difference, though, is that Spark can scale to lots of different computers, right? It's a distributed system, whereas Polars is like a single node system. I know Polars is building Polars Cloud. I think they're probably trying to
I saw that this week.
Spark, but research on this, So where Fenic kind of slots in is that it does share more of the DNA kind of with Polars and PySpark in that we are trying to build something that will have an optimizer, right? It will kind of understand what you're trying to do and see if it can rewrite the query in a more efficient way. And in the context of LLMs, that is, how can we send fewer calls to the models? Can we rewrite your DAG, rewrite your query plan such that maybe there's a way to like reorder operations such that like you can filter out data using a traditional filter before it gets sent to a model to do like a LLM based filter, right? That makes it so that you get the same exact results, right? Like semantically, your pipeline is going to be doing the same thing, but it's probably faster to run because you're not sending necessarily everything to the model, right? So that's one of the value propositions that Fenic has is that, and it's something that we're really excited to invest in more as the platform or as the product or the library gets more mature is what are these actual optimizations? Right now we have like some simple ones, but we're trying to build on top of that.
That's right. Okay. So just a quick question from the audience here, just about your code.
Yeah.
Did you use Rust to build the library? How much of the code is in Rust, C, Python?
Yeah, that's a great question. So the way that Fenic works actually is we have our own front end, a query front end, which is basically the way that you interact with the API. We've built that entirely in-house. We have our own expression syntax and our own expression library and our own logical plans. When we actually go and execute the code, however, any of the traditional like OLAP-y stuff, that gets lowered down into an actual Polars query, right? So we're basically transpiling the Fenic front end, which is kind of similar to PySpark, and it gets transformed and executed actually as a Polars query. Now, Polars itself is written in Rust, right? So wherever you can take any of the stuff and compile it down to Polars, that's actually running Rust under the hood, which is why we say that we're kind of like a Rust-based query engine. Now, for a lot of the operators that we have and a lot of the functionality that we have that is strictly CPU bound, that doesn't touch the model at all, like, for example, chunking, right? Like, chunking is just text processing. You can do a really fast job with that in Rust. That sort of thing, that we've written our own Rust functionality for. So if you look at the repo, I think it's like 88% Python, 20 or 12% Rust. All of the CPU bound stuff that we have added on top of the DataFrame ecosystem, that's in Rust. And then the rest of it is likely mostly through Rust because of how Polars is mostly through Rust. So you get Rust-based performance, even though a lot of the code's actually written in Python. Now, the decision to use Polars as our kind of execution engine is not necessarily something we're sticking hard and fast to, right? Like, this could change. It was just a way to kind of get the library out quickly and to sort of test some of the hypotheses that we had. So a really promising project in the space is a project called Apache Data Fusion. It's a Apache 2.0 project. And basically what it is it's a like database in a box, kind of, sort of like LLVM is for compilers, in that it has all of the bits and pieces that you would want to build a query engine. It has a front end, it has a logical plan, it has optimizers, it has an execution engine. And that is an area that we're considering exploring, kind of moving our back into, because it has a lot of the built-in optimizations and things that we can rely on, and we can focus on just adding like the new things that Fenic brings, and keep a lot of that same functionality that like core community has like spent so much time on making really fast.
That's right. That's right. Okay. Well, I'm glad we got you on the job here, Rohit, making sure that the back end is going to work well for us. And also, we definitely love your open source vibes. And I love the standing on the shoulders of giants vibes from the blog. So great stuff all around. But let's see how to actually use this tool next. I'm going to go ahead and introduce our build for the day. And then Wiz, obviously, it's go time, baby. Rohit, we'll have you back for some discussion after today's demo.
Sounds good.
So Wiz, this demo you're going to show us, this is basically thinking, the back end front end of his query engine is kind of the front end we're using here in the demo you're going to show us.
Yeah, I mean, there's been a lot of really great discussion.
Yeah, there's a lot of depth here. Yeah,
there's been a lot of really great description of what this is doing under the hood. We're going to look at how we use it. We're not going to dig under the hood in the small time we have remaining. The idea is, this is a very powerful framework, so we should think about this framework, and we should dive into it if we want, but using it is a lot easier than building it. So Rohit's already done all the hard stuff for us. Yeah. He's already worried about transpiling, and he's already worried about what query gets resolved where. We get the easy part. We just get to use the API and have
and you're going to show us a couple features here. You're going to show us semantic join, markdown processing, and data enrichment. So obviously semantically joining something, we're joining it based on the meaning rather than just on exact match. A classic, looking at the meaning instead of an exact match from evaluation that we teach a lot. And you're going to do this for content recommendations. So essentially, we want to sort of you imagine putting in the user has some interests, and we're kind of doing this recommendation, which is kind of cool that we have this whole like recommendation algorithm that we can kind of get out of the box. Just one simple feature here. And then you're going to show us how we take a paper from archive, like a classic, attention is all you need, and we can get a lot of really nice structured data out, starting with the OCR output and then going through markdown processing. And finally, starting with raw data logs. This was really interesting too, because we were just talking about this in an event on agent evaluation and like, how do we actually evaluate what happened with the agents? And like part of it is you look at the logs, and part of probably what you have to do as you start to evaluate those logs is like get it into some proper order to be able to calculate stuff based on it. And so I think there's just a lot of really interesting overlappy spaces here as we get into, feeding in data, whether that be used pre-app or even post-usage of the app to enrich it and make it quite useful. So over to you for the test drive of the Fenic Fox here, and we'll see. Is it dope or nope?
Is it dope or nope? That's the question we're here to answer all the time, always. Spoiler alert, it's not looking like nope, my friends. Okay, so first of all, what is Fenic? First thing, all the credit to Fenic. We're using some examples from the repo, from their examples repo. I've modified one of them to have a little bit of AI makerspace flair, which hopefully you'll be able to see. I don't know what's going on with Gemini, but it loves to be on my screen. What is Fenic? We've talked about it. We've talked about it a lot. This is straight from the repo. It's all of these things. The way I think about it is that we can shove LLM operations into a workflow we're already used to using, and it's going to take care of all that for us. Again, you can find their examples in the repo. We need to, of course, get Fenic, perhaps unsurprisingly, and then we're going to provide an API key. We are, of course, using an LLM powered framework, which means that we need an LLM. So we're going to be using OpenAI, but Fenic has integrations with most of the major providers. So I would be, use whatever your favorite is. The first thing we're going to talk about is semantic join. This, I think, is the easiest way to demonstrate why Fenic is something we should care about versus other frameworks right in this vein, which is this idea that we want to join things. We live in the future now. We shouldn't need to join things based on some programmed heuristic or some exact match. None of that. We don't want any of that. What we want instead is to be able to do what we do, like with things like RAG, right? Which is to combine things based on their meaning. And so this is what we're going to do. You'll notice that we have this config, or config is going to allow us to describe what we want to do in our session. So this is a session config. We're gonna give it whatever name we feel most happy to give it. And then in this semantic parameter here, we're going to provide a semantic config, which is largely a way that we can address our model, right? So this is the way we're going to tell Fenic what model we want it to use. In this case, we're going to be using GPT-4.1 because why not? It's a good model. And then we have our classic, rate limits and token limits to help us, not stress out our API provider based on our personal limits. And then we can create our session. If you're used to something like pandas, the idea of the session might be slightly more foreign to you than if you're used to something like PySpark and Polars. This effectively helps us this is all of the work that Rohit was talking about that he did, right? So this is the thing that allows us to do the cool stuff like our complex operations in a way that the framework is going to help ensure are happening, as efficiently as they can cobble our stuff together. The next thing we're going to do is set up some datums. In this case, we're just going to use JSONL. We're going to have some user IDs, some name, and then some interests. You're going to notice that these are talking a lot about John Wick. These are all different people that are interested in different John Wick movies. And then we have our actual content or our movie data, which is going to be about the different John Wick movies, right? We love the movie John Wick out here at AI Makerspace, all the way up to and including Ballerina, which is the newest John Wick. If in case you wanted to get more of the Wickiverse. Then we can create some data frames. We're going to use our session to create these data frames based off of that JSONL data. And now we're left with two data frames. We can show these data frames and we can print them and they look nice. They look like data frames. There we go. Okay. We love that. We love to see it. Hell yeah. Okay. Now we're going to go ahead and do the thing, which is join these two data frames semantically, right? So we have two data frames. We have this one which has names and interests, and we have this one that has titles and descriptions. We're not joining exactly on a column here. There's not really a good way that we can use some rule to determine what to join where. Okay, that's nice. So what we do instead is we use a prompt. This is called a predicate because that's what it's technically called, but you can think of this as a prompt. The idea is that we have a person with interests in left on would be interested in watching exactly one of templated to right on. And then we can see left on is our interests field, and then right on is our description field. Again, the idea is, right, that we have this understanding of our, we want to join these two things together, but we want to do it, based on meaning. So a person with interests, as we've described, would be interested in watching exactly one of whatever we've described, right? This is the big idea. So when we do this, we can see that our LLM is going to go ahead and chug through this. It's going to take some time. We're going to get some token outputs. We love to see it. But most importantly, I'm going to zoom out just 2 clicks here. You can see that it's done the thing. So now we have one data frame, right, with a bunch of new rows. And you can see that, Sarah, semantically related to John Wick and Ballerina. Mike gets John Wick 2 and Ballerina. Emily gets just John Wick Chapter 3. What a hater. And then David gets John Wick and Ballerina. Again, obviously, this is a contrived example, right? But it's meant to demonstrate that you can join these things based on meaning as opposed to, just some specific set of rules. Another thing to keep in mind, right, is that, this is the output we got, but this is a prompt, right? And the moment we see a prompt, we should think to ourselves, how can we make this prompt better? How can we make this prompt better represent what we desire, right? So this is a place that we can look to work beyond just our pipeline, right? Which is an interesting combo. And when we start moving out to these kind of many examples in a row, many transformations in a row, you can imagine that nailing this first step, right, is going to be very important in order to nail all subsequent steps. So a very, very important piece of the puzzle. Even though Fenic is awesome, it does not remove our need to fret about and worry about prompts. And you can imagine a world where you use some kind of framework to help make the best prompt here, and you get to combine 2 very fun libraries into one very fun exercise. Okay, and then we stop the session because we're done with it. So we stop it. There you go. We're going to look at Markdown processing. This one's a little bit easier. We're going to start with some big gross Markdown file, and then we're going to end with a data frame, which is better, right? Especially when we're talking about doing operations with, or especially as we're thinking about, something like RAG, where we care deeply about, referencing things or servicing the correct references to things, right? Our Markdown is great, but we're going to rely on the LLM to kind of guess at what reference we mean versus this process, which we're going to extract it into structured data, which is beautiful. Okay, we're going to upload a file. We're going to use the famous paper that I'm sure almost no one's ever heard of, which is Attention is All You Need. And we're going to use this Markdown extraction from the PDF provided by Fenic. We upload this to Colab, and then we go ahead and we load it up. This is just loading it up. We're going to load it into a single row data frame. So we're going to start with one row in our data frame, which is just the paper title, Attention is All You Need, and then all of the paper, right? Not very useful yet. I wouldn't call this meaningfully structured yet, right? We've just stitched it together. But now what we can do is we can expand this into a table of contents. So using Fenic, we can extract we can generate the table of contents, and then we can add that as a column, right? So instead of having our paper title and then just the content, we now have our table of contents, and then we can explode that into our, we're moving toward structured data here, right? So we go from just the paper title and table of contents to paper title, table of contents, the heading, right? So the heading it is, what level that heading's at, the content in that heading, the parent heading of the heading that we're looking at, and then the full path as described by moving through our headings. So this is the idea, right? We're already to a much more usable thing than we started with. And you'll notice again, we have each heading extracted individually, and the way we can do that is through our table of contents. I'm going to save you the rest of the scrolling, but you can hopefully see the idea. Then we can actually get the references out by themselves, right? Because we've already done the work to move from full markdown to table of content to each table of content item has the content that's associated with it. Now we can get to just the references. Just the references are very important because we have, this is what we want, right? This is what we're trying to extract. And then finally, we can use a couple different methods to actually get the references that we need. In this case, they're using JSON plus jQuery. Very straightforwardly, we have our paper title with our reference text. Each of these references is extracted from the references section of the paper. Very fun, very fun. And then finally, this is not, this part's not anything too new, but the idea is that we can use things like these templates to extract information from those columns, again, to get them a little bit neater and to potentially leverage the new structure we've added in the future, right? So this template is basically going to go ahead and rip the citation number out into its own column. Very cool. We love that. There you go. Finally, more LLM stuff. We're going to do some enrichment. So it's called log enrichment. Don't worry too much about the specific use case. The idea is pretty much the same as before, right? We're creating a session config. In our semantic parameter, we're telling Fenic what model we want to use. We're going to be using GPT 4.1 mini for this one, just because it's cheaper and it does a great job. Hooray. Again, you can set your limits here. These limits also something that Rohit touched on very briefly, right? Allow the framework to worry about, how much you're calling what when, instead of you having to worry about it, to avoid things that people from our boot camp will be familiar, which is rate limits, the bane of our existence. Okay, so we have a bunch of stuff. These are raw logs. They're not very useful for the LLM. Okay, listen, they're not wasteful. They're important. But LLMs, especially things like RAG or agents, like this is not great information, both to search through and also to understand it and how to work with. And then we have some metadata. This metadata is also important, but again, it's kind of in a less useful format for some kind of RAG system, right? We as users of builders of RAG pipelines, we know like this kind of thing is just not, it's missing something. So one of the methods that we have in RAG is something called contextual retrieval, which is where we augment the data that we're looking through with additional context. And this is what this enrich pipeline is helping us do. That's a bit of an oversimplification, but it is what's happening in this example. So we're gonna stick with it. But the idea is that we can create the two data frames that we want. We can create this from our our single column again data frame for our raw messages, and then our metadata df is already in this beautiful format, right? Let's go. Then we're going to go ahead and parse out using a template our log messages. What this is going to do is again move us from kind of this blobby weird format, right, which is not useful. Got a bunch of rows, which is dope, but one column of blob, not great. We can use this template, right, which is easy to construct in order to parse that out into a nice little structured set of information, right? We love that. We love to see it. Then we can join these. Now, if you notice, we have our timestamp level and service columns here, and you'll notice here that we have our service name, and we have our team owner, criticality, and on-call channel. The idea is that we can join these on that name. So we do so to augment now our initial log data with that service metadata, right? So every log is associated with a service. Therefore, we can augment each log now that we've extracted the services part of with the service metadata. And then we can do a bunch of stuff all at once. This is like the final boom. Okay, so we're going to go through it quickly, but it's very, very interesting. The idea is that we have this extraction, which we can do. We're familiar with through things like LangChain, right? Extracting into a Pydantic-based model, something that we've done a lot of times on this channel. We can do that as part of the work pipeline. Our semantic classification, right? We can classify into different buckets what the error log is based on the criticality. We can put them into these nice, neat buckets. And then finally, we can map this semantic thing or this prompt, right, across that data frame in order to help us get additional information. In this case, we move from this very basic log data all the way to beautiful, look at this, very, very operational data in a format that our LLMs very pleased about, that has a lot of natural language that's going to be useful for any agent that's consuming this data, or that's going to be useful to search through if in case we're using something like RAG. And this is the idea, right? All of this extraction, all of this classification, and all of this kind of prompt that we're able to map across the data set is handled for us without us fretting about it, without us worrying about rate limits, because we've already provided the information Fenick needs to make sure we're doing these things in a way that makes sense for us. There you go. Fenick, it's really cool. We're only just scratching the surface. There's a lot of depth here that you can go in. I highly recommend anybody to do that. These are just 3 kind of canned use cases, right? You can imagine that this is useful in a ton of other applications. With that, we'll go back to Dr. Greg. But before we do, of course, I have to ask you to like and subscribe and hit the bell notification. We're here every Wednesday at the same time. There you go. All right. Back to Dr. Greg.
All right. Thank you, Wiz. And it's time to wrap today. Thanks for the test drive on Fenic, Wiz. So, I think what we want to do is we want to get right into conclusions here, coming up on the hour. Remember, instead of having you do all the engineering work, we're seeing more and more frameworks all the time. Fenic is one of them that we think indicates the sort of path forward. This is really focused on that pre-processing step, but as we discussed, we could use it in a lot of other interesting ways. Classic LLM validation and eval techniques still apply. The folks at typedef seem really cool to us. Great open source vibes. And I do believe they are hiring as well if this type of work is something that you're interested in. I believe I saw that on their website. Fenic, dope. Let's go. So we got a final question that I'd like to sort of bring Wiz and Rohit back up to discuss. And it's related to one of the questions we got from the audience, because I think what we want to know, Rohit, is like, what are you guys doing exactly from here? Are you going upstream? Are you going downstream? We got the question. Let's see. Is there a plan of attack on, PDFs and OCR kind of going upstream? Or I think, we're particularly interested in hearing, are you going to go like into the agent application and like fully integrate it? Where are you guys thinking about this on your roadmap today?
Yeah, great question. What I encourage everyone to do if they're interested is actually to go check out our roadmap on the GitHub repo. It's all public, and we're pretty clear about where we want the direction of the product to go, or the library to go. But I think the answer is we want to go in both directions, really. So one thing that we want to do that the Wiz showed us is that we're really good at processing Markdown, right? Markdown is a first-class type. So as long as you can convert anything into Markdown, you're probably in good shape, right? So that's what we're trying to do as we build more ingestion integration, is how can we get data into Markdown? So there's a lot of ways that you can do that. You can do that with OCR. You might be able to use Mistral's models or VLMs to go from like a PDF into Markdown. And then from there on, you're in good shape because Fenic can handle Markdown. Or you can even do that with transcription models like Whisper, WhisperX, right? You start with a audio file, or in some cases even a video file, and then you can turn that into a Markdown-based transcript, which then you can process through Markdown and go through all of the semantic operators. So that's kind of the upstream side. Now, downstream, I think the question that we're really excited about is how do you actually operationalize the data that you've sort of curated with Fenic, right? You've run this pipeline. Now what, right? What do you do with it? Sure, you can make business decisions about it, but how do you actually give an agent this information, right? So that's what we're really excited about, is there are probably they're looking at possibilities of basically exposing the tables that you curate as MCP tools, right? That an agent can then go and hit. So you can write your Fenic query. It gets run in the background, and then you can define views over your Fenic queries, which are like kind of a database concept that indicate like how you can process a table further, right? And then you can expose that view, which is just a query at the end of the day, as an MCP tool, so that your agent basically has all the information that's required to like make all the best decisions you want. So all the context engineering stuff that you guys have talked about in past shows. So there's a few bits and pieces of that. Like right now, you could do that yourself. Actually, if you wanted, you could just wrap a table as an MCP tool. But we're going to build, some more first class tooling on top of like fast MCP to make that like really easy to do.
Okay. Any follow-ups here, Wiz? There's a couple of just tactical questions here that I think we should get to for the audience before we part today. Muted, getting owned.
They said it. I mean, yeah, Rohit said it all, man. It's it's just a, this is one of those tools that we may not use immediately in all things, but eventually we'll start using more and more.
That's right.
And especially as it's integrated into the rest of the ecosystem, it's just one of those things that we're going to get used to using because it's so good. And for a lot of us, there's not really a lot of getting used to it, right? And so it's just dope, on a scale of dope or nope, it's highly in the dope.
All right, let's go. Then Rohit, we've got a couple questions on like, joins are computationally expensive. Have you done any study on how these prompt-based joins, are actually looking on the cost versus performance end?
Yeah, that is a phenomenal question. And I think it is a very deep question. So the reason why joins are expensive, even in traditional joins where you're just trying to say, like, give me user equals user, across two different tables, is that if you were to do it in a kind of naive way, you have to pair all of the matches together by doing like something called like a cross join, and you have to evaluate the equality predicate for each row. So right now, that is the way the semantic join works, is that if you have like 100 rows on one side and then 50 rows on the other, we're going to multiply the two and then run the LLM question, the predicate on each row, on each pair. So yeah, that can like balloon quite a bit in complexity. So what we recommend that people do is kind of take this approach called blocking. So if you can basically filter out data before it gets to the semantic join so that you're only really matching around things that actually are likely to match or can match. Like if you know that things are unlikely to match, just like filter them out. And there's a few ways that you can do that. You can use like fuzzy string matching techniques. So we have a few APIs that are kind of inspired from the rapid fuzz library that some people might be familiar with, so that you can kind of use that to filter out some data early. Or you can use a less expensive, computationally less expensive join mechanism that we have called a semantic similarity join. So instead of actually running a prompt on both, you can basically embed the left-hand side and embed the right-hand side, and then do basically a semantic similarity search on the embeddings. So that is cheaper. And it gives you some like semantic understanding, but it's not actually going to the model, every time. So, and then there's another approach. So one thing I didn't mention that I really want to mention is that Fenic is inspired by a few research papers. There's one called Lotus that came out of, I don't remember if it's Stanford or Berkeley, both very smart. And then another one called DocETL. And they have some really interesting ideas around model cascading. So what that means is try to use a cheap model when you can, and then use an expensive model when the cheap model is unsure. So that's something that we're looking forward to, because you can maybe suss out based off of the log probabilities that you get out of the model how sure the model is. So if you can kind of process that, you can use a cheap model to basically scan the n squared data points, run the predicate on that, figure out where the model is unsure, and then only for the really unsure parts, then go send it to a really expensive model. So that's a technique that we're exploring to figure out how to like reduce the computational complexity. But for now, we recommend basically using some of the techniques I mentioned before.
Okay. I guess I have one final question, just because I get it from enterprises often. It's like, okay, so I got these docs, I got tables, I got charts, I got words, I got lots of stuff. Is AI ready today for this? if I got to use OCR and VLMs and Fenic and all the things to get it, is it ready? You feel confident about this as the expert here? Can I say yes to these people today?
I think with some caveats, you can say yes. Yeah. I think
Okay.
it's all about building the systems that are like kind of right for your use case, right? Like you maybe don't want to use this for like the most high risk thing because that probably demands some sort of like human in the loop. But if you're trying to kind of get roughly in the right ballpark for like a semantic analytics pipeline, I think you're probably in good shape as long as you understand all the failure modes and can kind of plan against it and figure out and really understand how these errors can compound and use the evals the right way. I think you're in good shape.
Excellent. Well, thank you so much for your expertise today, Rohit. We look forward to having you back again, man. Wiz, thanks for the demo. Guys, it's time to wrap up. Rohit, finally, if people want to follow you, is there a best place to do that? Follow your new releases, X, LinkedIn, whatever?
Yeah, so I'm on LinkedIn. I'm not really on X, but what you can do is give Fenic a star. You can subscribe to the issues that are in that and we're constantly adding more things that we want the community to help build. Check out our roadmap. You can kind of see like very clearly what our next steps are. And we plan to be pretty faithful to that. So
all right.
Please open up issues if you want things on the roadmap to change, issues that you have when trying to run the demos or building your own applications, and we'll be super responsive and try to get all those fixed.
Yeah, and we'll drop the roadmap in the comments. I couldn't quite find it live here. But thanks again, Rohit. Thanks, Wiz. See you next week, bud. All right. Thanks, everybody, for coming to check out Fenic from typedef.ai. We hope you enjoyed the discussion today. Great chat going, everybody. If you're not yet in our Discord, now's a great time to jump in and join the Discord, start building, shipping, and sharing with a bunch of the legends you saw in the chat today. Next week, we are going to cover the brand new open source models from OpenAI. So watch your inboxes for an RSVP invite coming soon. That's going to be something that obviously is pretty exciting. Open AI. And then, of course, we've got our AI engineering bootcamp starting in a month. This is going to be cohort 8. We have been absolutely blown away by the level of getting after it that we're seeing from cohort 7. They all just submitted really incredible projects for their certification challenge. If this is the kind of thing that you're interested in, check out the AI engineering bootcamp. We've made it even harder to get into than ever before because we're just seeing incredible quality of students coming through. And if you're an enterprise and you're looking to get your team trained up, or you're looking for some advice on where to go with your strategic roadmap, feel free to reach out to our team. And with that, thanks everybody for joining us. We look forward to seeing you next week. Same time, same place. You know the drill. Until next time, keep building, shipping, and sharing, and we'll do the same. Have a good Wednesday, everybody. See you soon.
But Greg, how do they get started building, shipping, and sharing?
Getting started is the hardest part, like it was for you and for me. You can get started with the AI Engineer Challenge, and you can share it in the Build, Ship, Share channel on Discord. Links in the description. What if they want to accelerate their ability?
Well, we actually have a 10-week intensive bootcamp where you learn to build, ship, and share production-ready LLM applications every single week.
The AI Engineering Bootcamp, cohort starting soon. We'll have you building, shipping, and sharing
like a legend
in no time. We'll see you in class.